It's okay. Swisher's coming up next. PS9, or we look for it? Okay. There's a sign-in sheet back there. You drop your name. You might have turned that microphone back on. Yeah.
There we go.
Yeah.
Yeah, I just turned it back on. We should be good.
Joining us, I think I'm over there.
Gonna have just about 15 or 30 minutes to help set up there. So I'm gonna sit down.
Yep.
All righty, I guess we'll get started with introductions. So welcome. This is, I can pronounce it. We're evaluating PS9. So today I have the pleasure of introducing Alexis Ferguson. She works as a technical lead in the refinery and petrochem space for a DAS company, ESC Spectrum, which, full disclosure, we both work for the same company. She holds a bachelor's degree in chemical engineering and has started working as a DAS implementation engineer in the power gen clients. Over the past 4 years, she's been focusing on designing, implementing, developing standards for refineries and petrochem space. She has helped her coworkers as she's a technical resource. Outside of work, she's an avid board gamer hobbyist and always brings a game on attitude when it comes to meeting DAS standards. So with that, I will let her share her experiences with PS9.
All right. Good. Still morning. Yep. Still morning.
Doesn't feel
Welcome. Yeah. Can you hear me in the back all right? Okay. Sounds good. So we'll specifically be focusing more on PS9 as related to flares. Just as a warning, hopefully that doesn't mean I lose any of you. But what we'll be first covering in this is just kind of a recap of Performance Specification 9 and going over specifically what that performance specification requires, as well as then covering and leading into the MAC-CC specific requirements for PS9 and what the regulations specify there. Then the additional PS9 documentation that's been released for MAC-CC, and then interpretations and implementations that we've seen our clients want to do for evaluating PS9 readings for MAC-CC. And then finally, we have how that relates to the MON-MACT and EMACT requirements. Lastly, so Before getting into that, some clarifications. When we say there's a calibration versus validation, you'll kind of hear the two interchangeably, but typically calibration refers to the process of calibrating an analyzer to a known standard and reading that concentration as the known value of we have the standard, we have to make sure that this analyzer is reading the standard to the standard. And making sure that that reading is accurate. Whereas validation is typically done on a daily basis and relates more to making sure that the analyzer is properly calibrated. We have a calibration gas. We are making sure that that analyzer is within is reading that gas within tolerances. And if it isn't, then we go back and we calibrate that analyzer and make sure that it is reading within the tolerances that it needs to. So for the purpose of this presentation, though, anytime calibration is used, assume that validation is attended and that the two are just kind of being used interchangeably. So for a full PS9 recap, just directly from Performance Specification 9, that's Part 60, Appendix B, Performance Specification 9. Requires validation gases based on pre-survey sample analysis as to what those gases need to be. In 7.11, we have a low level that is 40 to 60% of that pre-survey sample. Then we have mid-level, that's 90 to 110% of that analysis. And then high level is 140 to 160 or the highest expected concentration. We also have requirements for a performant audit gas. This is a mid-level certified EPA audit gas. I have this asterisk there because of the underlying portion that if a certified EPA audit gas is not available, use a gas manufacturer standard accurate to 2%. What we've seen is that our clients often aren't able to get a performance audit gas for the gases that they are required to validate. And as far as I know, no one's been able to get them for the PS9 requirements. Well, there's also an FAQ that goes into that EPA audit gas a little later that we'll touch on. So within PS9, we have the first requirement as for a multi-point calibration. So we have to perform that after initial start of the GC, routine maintenance and repair, or at least once a month. And that's run for each target analyte. With that, there is a triplicate injection for each level. So that low, mid, and high gas that we talked about, 3 injections for the low, 3 for the mid, and 3 for the high. And the average of each injection, we then average each injection level and compare that against that low, mid, or high reference gas for whatever that gas is supposed to read at. And we make sure that the average of those 3 injections for each level is not differing more than 10% from their respective gases. And then we compare each of those injections against the average for that injection level. So the 3 low injections, those for that low level, the average of that level is then compared against each individual injection to make sure it doesn't differ by more than 5%. And lastly, we perform a linear regression using each of those averages at each injection level with making sure that we get that linear regression with an R-squared value greater than or equal to 0.9595. So just to kind of break that down a little easier because that's a lot of information there. So we'll have a total of 9 injections, 3 for each of those levels, the low, the mid, and the high. Then Injections for each level, so all three of the low injections would be averaged together, all three of the mid injections averaged together, and all three of the high injections averaged together. So we'll end up with a total of 3 averages from that. Then from there, we calculate the error against the cylinder concentration and make sure that's less than or equal to 10%. What we then do is retroactively take those averages back and compare each one of those average against the 3 injections that were done at that level, and compare that against the average and make sure that's within 5% of the average. And then lastly, all 3 averages are used to then calculate a linear regression. And this is by far the most difficult part of this, where the calculation itself isn't too bad, but the just difficult to meet this requirement of proving that linearity out to 0.995. This is the step that a lot of the tests usually fail on. They might pass the other 2 and then fail this one. Normally, the individual injections and average are pretty spot on, but making sure that that's linear is where the difficulty normally lies as far as sites passing this test. So for an example, just to show you some numbers, we have a low injection results. Say we have 12.41, 12.52, 12.59. We would then take each of those injection results and average those together out to 12.50. Then we look and see, okay, what's our low level cylinder gas concentration? Well, say it's 12.55. Using the equation 9-2 specified within Performance Specification 9, we then take the absolute value of the cylinder gas concentration minus the injection average divided by that cylinder concentration. So using the cylinder concentration as our point of reference, and then multiplying that out by 100, we're pretty close, within 0.4%, which is well within tolerances for these requirements. Then we would compare each injection against that 12.50 average. So we have that 12.50, subtract out that first injection result, divide that by the average. So now the average is our point of reference. Multiply that out, and we get 0.72%. And then we do the same thing for the other 2 averages that we have. And then after doing all of that, that is then done again at the for each of the mid-level injections and high-level injections. And that way we end up with those 3 separate averages for each of the low, mid, and high levels. We have a comparison against each injection result, and then taking all of those 3, that's when we get into doing a linear regression, which say this is kind of what our data looks like for the SIMS response for that low level, then our mid level, then our high level, and the reference value for each of those levels on there. So we would use equation 9-1 specified to do a linear regression, which you can do pretty easily in Excel with just a table and plotting that out. And you can see we then use this calculation to calculate linear regression to 0.997, which is meets the requirements of being greater than or equal to 0.995. So beyond the multi-point validation, which should be run anytime there's maintenance or initial certification, or on at least once monthly based on exactly PS9 as written. There's also the daily. The daily is at least once every 24 hours, and this one's a little easier. It's just the mid-level in triplicate. So there we would have just 3 injections instead of 9. And then that's just for the mid-level, and those are averaged together. So we'll end up with one average from those 3 injections, and then we just have to make sure that that average is within the cylinder concentration. So there's no going back and having to verify each individual injection within percentage of that average. So now looking at how MaxCC kind of shifts and changes those PS9 requirements. MaxCC gives you 2 options for the cylinder gases that you need to use. You either have the surrogate calibration, which is going to be the C1 through C5 normal, so your methane, ethane, propane, butane, pentane, and hydrogen as an option. If you go with this option, it is specified that to use the response factor for the nearest normal hydrocarbon for when calculating and detecting unknowns in the analysis. So if you go with this method, a lot of sites interpret this as, all right, for our net heating value calculation, in anything that is not C1 through C5 normal or hydrogen, we need to classify that as what the nearest hydrocarbon to that analyte is, and then use that analyte's value as, say, for instance, ethylene would be then used as ethane in the net heating value equation required by MaxCC. So the other option is option 1. This one specifies to calibrate also using C1 through C5 normal, hydrogen, and then additional gases. We have the ethylene, propylene, isobutane, butenes, 1,3-butadiene, and then optionally acetylene, carbon monoxide, propadiene, and hydrogen sulfide. So that's a lot more gases, and those cylinders tend to be a lot more difficult and more expensive because of more gases. So why would you choose these additional gases and that method instead of the surrogate method? Main reasons that we see is either permit requirements or state or county requirements, such as TCEQ, HRVOC requirements, require the gases in the non-surrogate method, or consent decree requirements, where those would limit you to having to use the full list of gases instead of that surrogate method. So additionally, in MaxCC, we have this specification, and this is the only specification for an out of control period. It specifies that you are out of control if the low, mid, or high level calibration drifts exceed 2 times the accuracy requirements of Table 13 within MaxCC. So for that, we then look to out of control in this context, meaning to exclude that data from your compliance calculations, and it counts towards downtime because you have exceeded your tolerance for the analyzer. You need to recalibrate that analyzer, and any of the data in between when you went out of control and have successfully recalibrated and verified the analyzer would be excluded from your compliance calculations as a result. So if we look at exactly what Table 13 says, Table 13 then points to Performance Specification 9, except it gives a couple of exceptions in there, mainly that a daily mid-level calibration check can be used. So instead of doing a triplicate injection on the daily, you can just do a single injection. And so instead of having a triplicate injection and then averaging those and comparing the average against your cylinder concentration, you would just do a single injection and verify that that is within standards. And then it also allows for the multi-point calibration can be conducted quarterly instead of monthly because PS9 specifies monthly. This allows you to just do it once quarterly. So we have this requirement for 2 times the accuracy requirements, and that then points to table 13, which points to PS9. So just kind of a bunch of looping around to find different sections of the regulations. So with this, many sites interpret that to mean that there is that 2 times the performance specification of PS9 is acceptable for least considering data out of control. Where before we start getting taking that data and excluding it from our compliance calculations, we would have to get to 20% error as opposed to 10%. And this is also dependent on permit and local requirements and consent decrees, as well as in your own interpretation and judgment. But we have seen sites have this interpretation. We've also seen sites have this interpretation, but they find out that they are limited and can't actually use the 20% instead of 10% because it's specified elsewhere within either their a specific permit requirement or consent decree or local requirements that aren't allowing them to do so. So other key difference is that single mid-level injection daily instead of the triplicate mid-level daily, and that multi-point quarterly instead of monthly. So 1 daily injection, and then compare that against your gas concentration, and either make sure it's greater than or less than or equal to 20% error or 10%, depending on your own interpretation and requirements that you need to meet there. So additional documentation, Alt 124, we had this in February of 2018. Fun fact is that there's a little asterisk next to the 124 because this was originally labeled as Alt 119 with a link to that. The link to it said Alt 119. That has since been fixed though, and that is the link was corrected to correctly identify it to Alt 124. Which if you go to EPA's website, it now says Alt 124 and the link says Alt 124 instead of what was happening before where the link to it was saying it was Alt 119. So in some documentation, you may see people referencing Alt 119, just be aware that they're meaning 124. This was the industry-wide approval to use a mass spectrometer for MAC-CC requirements instead of a gas chromatograph. So instead of just a GC, which PS9 was originally written for, we're allowed to use a mass spectrometer, and that is because there's a little bit of there are a little bit a couple of things we need to consider there with using a mass spec instead of a GC, since the rule was originally written for a GC that we'll get into here later. With Alt 131, that was in December of 2018. This allows for the pass-fail criteria for PS9 calibrations to be based off of the net heating value instead of the individual gas components for GCs and mass specs. So you'd still look to each gas, but in terms of pass-fail criteria, you would calculate out the net heating value that you're using for the net heating value of the vent gas and compare that against the net heating value of your cylinder concentration. You must, to do this, you still have to use one of the gas options specified in the 63671 between the surrogate method or the full list of gases. So to just kind of give you an idea of why this net heating value was done and how beneficial it is. Just looking at two examples here, a lot of the heavier components, the butanes, pentanes in these cylinder gases were very low concentrations, like in the 0.9, 0.7 kind of range. So slight differences in there, since we're using the calibration standard as our point of reference for calculating error. The smaller concentration ones were resulting in fails of just being a couple decimal positions off. Whereas with the net heating value, you can be off by tens and still be within the tolerances. So this also raises the question of why wouldn't you use this? And the answer is also typically because of some permit or local requirements or consent decree requirements that force you into the other option. So in addition to those documents, we also have PS9 FAQ. This was released in March 2019. A lot of people had questions about PS9 just because of the complexities with the regulation and various interpretations. So some quick highlights from this is one, if it's all right to add additional components to the hydrogen C1 through C5 blend. And they say yes, but they should not be used in the net heating value concentrations. Going on further, question 8 just provides a list of how often you must perform those QA or QC calibration assessments. It's just a handy list to have spelled out plainly for you so you can remember when all of these need to be done. And then our quarterly multi-point calibrations and performance audits, both required, or are they essentially the same test? This was what clarified that the performance audits are mid-level calibration gases injected 3 times through the sample transport system. So going back through and requiring for that performance audit doing a triplicate mid-level injection instead of a low, mid, high injected triplicate multi-point calibration. So both of those, they're 2 different tests and need to be, both must be performed. This is another kind of interpretation area where I've seen people take their PS9, their full multi-point PS9 results and flow those through the sample system so that they could use the mid-level as part of their performance audit. But that also depends on your interpretation of this and the next question even more so because it's a question on the calibration standards. And the multi-point calibration standards can be used to meet the requirements for performance audit checks. And this spells out that the intent was that the performance audit cylinder was a more rigorous gas procedure, if possible, or from a second source. And this last part of from a second source seems to indicate that you might not want to try to use your triplicate PS9 test that you ran through the sample system for your also for your performance audit. With that performance audit, just specifying this out again, 3 injections averaged together and 1 average, and then that compared against the cylinder concentration to make sure it's within 10%. So various implementations and interpretations we've seen is we've already covered the PS9 multi-point versus the performance audit, and if we're considering the performance audit gas to need to be from a different source, do we then need a third mid-level gas that's separate from the daily mid-level gas and the multi-point mid-level gas? Is that another third gas that needs to be different, or can all of these be the same gas? And then can the net heating value be used for pass-fail determination if gases must be split between multiple calibration bottles? So say, for instance, we couldn't get all of the individual components into one gas cylinder. How are we supposed to take the net heating value calculation and use that for pass-fail calculation and to determine that status? And some people say yes on this, some people say no, as to if you can still use that Alt 131 because of this excerpt right here. That seems to indicate it needs to be a single gas mixture. But again, it depends on your interpretation. This is a section that the regulations pretty silent on, as well as Alt 131 doesn't really have a great specification on. So if we are going to say that we can use that net heating value for that pass-fail determination if the gases have to be split between multiple cylinders, how are we to do that? A couple options we've seen is compare the net heating value of each individual cylinder against the analyzer response. So in this case, instead, the multi-point would have 4, 5, or 6 cylinders. And then for each average of each one of those cylinders, use that for in the linear regression, and each injection check to verify that they're within 5% of the average. So that's error determination done basically triples the amount of calculations required if you have 6 cylinders instead of 3. And then the other option we've seen is we calculate the net heating value for each of those individual components and add those together across multiple gas cylinders to kind of replicate a single net heating value, even though the percentage of those gases might then be above 100%. And that kind of then replicates just the 3 injections as we were doing before, instead of, and 3 averages instead of upping the number of averages that you have. If we now look at the MONMACT and EMACT requirements, they largely point to MAC-CC, but in them, it does specify the ability to use a mass spec and net heating value in those requirements instead of having an alt like we had for MAC-CC. Other than that, the requirements are largely the same. So in summary, we've seen a pretty wide variety of interpretations that aren't standardized very well across the industry. So you want to be detailed in your QA/QC documentation of what you're doing and the why reasons behind that. Just because we're seeing this much variety between those interpretations, and there isn't quite as much spelled out for the areas that the regulations are silent on. MONMACT and EMACT will face the similar concerns that we've faced in the refinery sector for a few years now with MAC-CC. And for any allowances or new interpretations that you might have, you'll want to verify those with permit or local requirements and consent decrees to ensure that they can be used, such as the surrogate gas method using the net heating value for pass-fail determination, and 10% versus 20% error threshold for your daily validations. And along with the daily validations, I don't think I mentioned this, but when those do fail, you're then required to do maintenance, which then requires you to then do a full multi-point PS9 to be considered back in control and to have passed and to pass that validation. So that was a lot of information. We're pretty close to time. Does anyone have any questions?
Somebody's doing 6+ C-pop,
Mhm.
they're 10% bottom 10. My experience with hexane and yes, and they're get to 10, yes, which is negligible amounts of gas. Are you seeing? So what are you seeing people do when they've got significant concentration?
So for those concentrations, it's unfortunate because you then run into issues with your cycle time and making sure that you're getting that value or that gas to the probe and back quick enough to be able to work with that. As far as that goes, I'm not too familiar with the sort of techs and how they would do it, but I have seen techs be able to kind of up their flow on that gas with the pressure and just flow more of it. They run out of that gas faster, unfortunately, but they're able to at least meet that as cycle time requirements.
Not easy though, right?
No.
We're seeing that situation deviating from letter of the or we're keeping the heavies in a technical gas. So we're doing all we can. It's certainly the benefit of I don't have enough pressure, I don't have enough volume that cylinder to make that gas worthwhile. What I can do is I can pull the heavies out and fill another cylinder, a technical cylinder, for photography purposes and calibration purposes. And we do that on a not as frequent basis. It does not need letter of the rule happening session somewhere because as soon as we're adding those heavies in there, your gas so basically. Other than that, we have actually utilized cylinders that are compress the liquid, and then you have a vaporizing regulator, and that works a lot better for the heavy. Or to deal with little propane grill tanks, full propane, they put the heavies in there, and those things last a long time. And set up right, thought through the vaporizing regulator, works really, really well. It's not capital intensive. There's the other way to get your head. In propane, liquefy, and vaporize it. And then that's where you get into like what was talked about with that split cylinder. We would have the lights in a regular air cylinder matrix, and then we'd have the heavies in. It's tricky because you're playing. You're really so this is a ballet, like selecting your gases.
Anything else? Okay.
All right.
Well, thank you very much.
We also have a software demo up in room 614 upstairs if any of you are interested to see how our DAS software handles these PS9 calculations.
And if you haven't signed the sheet, I'd appreciate you signing the sheet.
Jeffrey,
Thank you, Alexis.
Good.
It was funny going back and listen to that because we have all these nuances discussions where they all came. Stuff.
Yeah, there's just so many different sources that we're pulling from, and yeah.
We interpret the PS9